have a look at these questions quickly. So what is a compiler was asked. This was the first question asked in May 2019. What is a compiler? Compiler is, you can say a translator, right? Basically, the kind of language we call C as high level. Okay. You will be writing the program in English like language, right? So, but the computer understand the machine level code, right? Machine level code in the sense binary code, rather, right? Binary code. Basically, the number system based on which the entire hardware is built is binary number system. Okay. So on the computer, right? The communication that happens across the different devices that you have as part of this bigger machine, like input device and the output device and the CPU, right? So the communication between this happens using the binary language only, right? It's a stream of binary data. So computer understands what binary language. But in C language, you will be writing the program in English-like kind of. For example, you are writing, let us say, addition of two numbers. How do you write? You take two variables, A, B. Then you initialize some values for the same. Then if you have another variable C, let us say, in which you can have the result of the addition of this AB that you obtain, then you can print the same using printf statement, right? So here, if you see the program which you have written starting with the main function, right? If there is no main function, there is no execution at all. Every C program must have a main function from where the execution starts and terminates. So the function will have some set of instructions, fine, enclosed in the braces. This brace is said to be the begin of the main function, right? So main is having a block of instructions. So beginning of the block is identified by this opening brace, said to be opening brace, right? Then you will have some set of instructions. Then you will have the closing brace, right? This is the end of the block. So inside this, you have written some code, like you have first declared some variables A, B, C, and you have initialized some values to A and B. Then you have added this A, B, and then transfer the result in C. Okay. So, and then you are printing the result. Fine. So this is, you can see the entire code which you have written is understandable by any novice person, right? In a user language form. But then computer does not understand this, right? Then it must have to be converted into the machine understandable form, right? So machine understand the binary language, right? Scheme of bits, binary bits. What does binary number system consist of as its digits? It will have two digits. Binary number system consists of two digits, 0 and 1, right? So all the data which is available here, has to be converted into stream of zeros and ones. So who will convert that? Compiler. So compiler is the other way around, you can say is a translator. So this compiler is going to convert this high level code, this is your high level code, are the user level or user understandable code into the machine level code, right? Into the machine level code, right? So So compiler duty is to translate so that the machine can understand the code which is being generated by the compiler. So compiler generates what? Object code, right? Compiler generates object code. Okay, so the object code consists of what? Binary information stream of zeros and ones. Okay, so this is what the advantage of compiler, of course, right? But then how compiler convert this all? It's an entire process. It's a process of steps. It first converts. It understands first whether the sentence is well formed or not, whether the sentence is syntactically correct or not, right? By checking across with the grammar rules. So there is a process, of course, right? For which, of course, you can refer my YouTube videos, compiler implementation, interpreter implementation. I have a chapter discussed on this. Okay, I'll show my YouTube channel. There you can find, if you are interested, how the compiler basically converts the high-level code into machine-level code. What are the phases across which the code will go through, and then it will be finally generated as a machine-level code. For that, I have a YouTube video which is in my channel. You can just go to that respective video implementation we have, right? I have a title called language implementations. There are three type of implementations you find across all languages. It could be compiler implementation like C, C++, and other kind you have the interpreter implementation, means compiler or interpreter, both are of course the translators, but the way they perform is going to be different, right? So interpreter implementation, for example, Python, all scripting languages like PHP, JavaScript, VBScript, Lisp, these all things, these all languages are interpreter based, right? So the implementation takes place using interpreter. The conversion is being done by the interpreter. And you have some languages wherein the translator is a hybrid kind. Hybrid is a mix of both. It's a mix of both compiler and interpreter. Like for example, Java. Java is an example of hybrid implementation. You will have compiler. Compiler will convert the high-level code into the universal bytecodes, or you call it as Java bytecodes. Then these Java bytecodes are going to be interpreted on the JVM, Java Virtual Machine, which is built in all the browsers and operating systems. So without having the Java software being installed on any machine, you can run the Java code, provided JVM is available, and JVM is available in every operating system, in every browser. So you can directly straight away execute the Java bytecodes. Okay, Java bytecodes are being generally generated out of the Java compiler. Java compiler generates a .class file. So this .class file you can take on to any operating system or browser, and you can run the Java program. So there, when you are running the Java program, interpreter takes the conversion of your Java bytecodes into the machine understandable code, that is binary language, right? And then the execution will take place in the next step, of course, right? Since it is having both compiler and interpreter, is the reason why we say it is a hybrid kind. So we'll have generally three types of implementation across any programming language: compiler based or interpreter based, or you will find the hybrid based. The next question is difference between object code and executable code. Okay, I have just now discussed what is object code, right? What is object code? When the language, when the compiler is going to generate the object file, that object file is itself carrying the object code, which is nothing but the binary code or the binary information. Okay, that is said to be the object code, right? So you have source code. Source code means your program, right? So you give the source code to compiler, and compiler generates the object code. Yes or no? So this object code will have the data in the form of binary. Okay, good. Now, what is executable code, right? So after you compile, then what do you do? You will go for execution. You have different procedures for execution. If you have generated an object file, then you will execute it with the help of, you know, how do you execute? Dot slash a dot out is one option, right? Dot slash a dot out. Dot slash a dot out, right? And then what happens? Dot exe file is going to be generated. This is your dot C file that is said to be the source code. When you compile with the help of compiler, how do you compile? You have command called cc, then you will have the file name, right? Dot C. What happens? The compiler is going to convert the object code. This is represented with extension .obj. Okay, this is your object file. And now when you execute with the dot slash a dot out, you will get the .exe file. Okay. So now the difference between object code and the .exe file is object code is understandable by linker. Okay. Linker. But there are certain references in object code which are not being resolved, right? Which are not being resolved. For example, you have some program written wherein, for example, in every program you must be using some functions, right? For displaying the output, for accepting the input, like printf, scanf kind of thing. This printf and scanf kind of thing, okay, this printf and scanf, actually they are the library functions. They are available in stdio.h. Yes sir. Now when you want to execute the program, before the execution takes place, printf and scanf has to be made available for the system, right? So in the object code, you will have the references that this printf and scanf is available in stdio.h. But then your .c file, your .object file is not linked with the header files. This header file consists of some pre-processed functions like printf, scanf, and all kind of thing, ready to provide you the services, right? But they are not, resolved. It means they are not linked. So the linker comes in picture before the execution. Okay, when you basically execute, the linker comes in picture. What he does, he will resolve the references. So printf, scanf, which are available as part of the main program, are available in stdio.h. Then it will take this reference and then make these functions available in library to be linked with the obj file, right? Your object code. Object code is the code which is being generated by the compiler, but it will have unresolved references which were unresolved in object code are being resolved with the help of linker and loader, right? This is the difference. The next is, what is the output of the following code? So you have a percentage %d. Percentage %d is a formal specifier to print the integer value. So in place of this %d, after double C, you have I plus plus. So this is said to be post increment. So what happens, the value will be used, means I value is 5. 5 will be printed here. So you get 5 here. after the value being printed here, I value will be incremented for binary search. This also we have discussed in the class. If you have any doubts, probably I can still discuss it. Rather, if you want function, you can say sum of digits. Okay, if you want to pass the number as an argument, you can rather pass the number as an argument. The code I have already discussed, the logic I have already discussed that I'm writing here. So there is a variable not equal to 0. What did I say? Sum plus equal to n mod 10. Okay. The next we have is the number to be reduced. So n by equal to 10. Okay. Now I'm terminating the while block here. The result will be available in sum. So I'm printing that result here. So printf. So yes. So the algorithm for binary search here it is asked under 2 marks. So you can just write the entire code. Binary search lower bound, upper bound, and the array, right? Fine. So here you can write in English also because it's just a 2 marks question. So what do you do? You will be passing even the key to be searched here, right? Rather. So, yeah. So algorithm binary search, taking arguments like lower bound, upper bound, array, and then key. Fine. Then here the first, if key is less than middle element, then move to the left half of the array greater than the middle element, move to the right half of the array. And third case is if a key is equal to middle element, then say key is found. Okay. Okay. Otherwise, you have to repeat the above process. If you consider this as the step 1, okay. So repeat step 1 until array exists. Until array exists. Out of this loop, you are going to say otherwise. What you are saying? Otherwise, print T is not found, right? So this is your algorithm. You can define recursion with an example. A recursive function basically alternate to iteration, we say, and recursion is another calling a function within itself. For example, factorial of a number if you want to implement using recursion. How do you do that, right? I have taken the function as a fact here, return type is int, and we have taken an argument int n. If n equal to 0, return 1, we are saying, otherwise, what is it you are saying? Else. Return n into fact of n minus 1. Okay. So this is the code, right? You can see here, this is an expression. Return followed by n into factor of n minus 1, right? So in this expression, you can see there is a function call. What is a function call? Again, the same. You are calling the same function within itself, right? This is said to be recursion. But you can give this example for this. What is the next question? How to access structure element? Give some examples. How do you access the structure members or structure elements? For example, you have a structure student, right? How do you define the structures with the help of struct keyword, right? So struct followed by student. Let us say it consists of some numbers, student number, student marks, okay, and student names you have. Let us say asterisk. You can use almost array or a pointer to declare a string. Okay. Okay. So now you want to implement this for one regard. So you can create a variable of this at the time of definition like this, or you can create a variable afterwards also by having a statement struct followed by the student and followed by the variable name. Now we want to access this element. The question is how to access the elements. S number, marks, and S name are the elements. So how do you access it? With the help of membership operator called dot. Right? Very good. Very good. So S dot S number, or you say S dot marks and S dot S name, right? So this example you can give here. Now the next question is how to bring out the examples. Bring out with examples. Differences between array name and pointer. Okay, so what is the difference between array and pointer? Yes.
Pointer points to the address and array name total.
Yes. While declaration, how do you declare an array? With the help of square brackets, right? So any variable followed by square brackets is said to be the array, right? So you declare like this. But how do you declare a pointer? With the help of asterisk, right? Asterisk followed by the variable. We call this as indirection, right? Asterisk, or you can call it as a dereferencing operator also when you are trying to access the element being pointed with. But at the time of declaration, we call this, as indirection, right? Because pointers are being used to access the variable of same type. You want to access another variable of the same type, right? With the help of pointers. So basically for pointers, how much memory is required to hold the address of 1 byte? For example, if you have 32-bit processors, right, you need 4 bytes of memory. Fine. If you have 64-bit processors, then it needs, 8 bytes. If it is a 16-bit processor, it is 2 bytes. So it requires the memory to hold the address of 1 byte. So it holds the address of memory. It holds the address of memory, right? So with the help of pointer, for example, you have an array declared here with 10 elements. So 10 elements memory been allocated for this array, and all these elements can be accessed through indexing mechanism, like A of 0, A of 1 like this, till up to A of 9, right? And now let us say the base address, the first element, first byte address is 100, which can be placed in pointer with the help of this P equal to A statement. If I say P equal to A, what happens? A array name holds the base address. Basically, array name itself also acts as a pointer. Array name holds the base address. Base address is 100. So when you assign this to the pointer, what happens? In P, you get this. Now through P also you can access this entire thing. And you want to access this array with the help of pointer. How do you access? With the help of P plus I, right? Use asterisk here. asterisk replacer. Asterisk here basically works as value at the address being held by fine memory. So you can access it. You can access the array with the help of indexing mechanism like a of I, where I being varied between 0 to 9, right? Or you can access it with the help of pointer through p plus I, right? So you can give the difference by comparing the way you declare the array and the pointer, the way you access the array, the way you access when a pointer is pointing. Fine. This way you can probably discuss all. Taking one example, I have mentioned this example. You can take this example or any other example. You can probably take and then explain. Okay. What is the next question here? What is a stream? Okay, stream, data stream. The data is available, text or binary form basically. This the file structure. If you look at, the file consists of, you have binary files. So binary file consists of binary stream, and data file consists of data stream. Okay. Fine. Now coming to long questions here. What type of long answer questions were asked here? The first question was, write the algorithm for determining the remainder of a division operation where the dividend and divisor are both integers. So how do you find the remainder out of division? Using mod operator. Okay. So here you have to write an algorithm. So just say algorithm and say remainder. And you can start begin with, and then you need some variables here to declare. So you can just say declare that variables ABC, or you can say, integer ABC also, like how you do it in C programming language. However you want, because algorithm is a basically kind of pseudocode which can be understandable by any novice user. So now you have, let us say, initialize some values to this AB, because here he asked us to implement it for integers, so we have taken these variables as integers here. Now we can initialize some value to A, we can initialize some value to B, perform the mod operation, A mod B, right? A mod B. Then it will give you the remainder here. So this remainder you can rather print. Right? Print remainder. What is the value you have? C. You can end the algorithm. Fine. So this was the first question under the long answer was asked. Then next, what is the next question? Draw a flowchart for printing the sum of even terms contained within the number of 0 to 20. So how do you find the even numbers? The help of 2 into I, where I is being varied between 0 to 10. Okay. If you substitute I value 0, you get 0 here. If you substitute I value 1 here, you will get 2. If you substitute I value 1, if you substitute 2, you will get 4. So these are all the even numbers till up to 20. So what was asked? You are asked to draw the flowchart for printing the sum of these even terms. So first we try to design the logic for the same. Take a variable sum. For sum of series kind of programs, you initialize the variable in which you are trying to accumulate it with 0, the identity value. ID to identity is 0 here. Then you can take a for loop here where I can vary between 0 to, anyway 0 doesn't matter, so you can rather start with 1 itself. Fine. You can say one iteration here, so you can start with 1, I less than or equal to 10, I plus plus. So what is that you're saying? Sum equal to sum plus 2 into I. So 2 into I. So this is your logic, right? But then you are asked to draw the flow chart for the same. Okay. So how do you do? Shall I erase this? Yes. Okay. So how do you draw the flow chart? Start with the start symbol. Then
Declaring.
you will declare the variables. So what variables you need here? You need I here. You need sum here. And what else you need? They're enough, right? So declare the variables. Then initialize. So what is that you're going to initialize? Sum you are initializing with 0. I you are initializing it with 1. Okay. Now you are going to add here first even number. How do you get it? Sum equal to sum plus 2 into I said. Okay. I is initially 1 now. So 2 into 1 is 2. That will be accumulated. Then next is increment I. So I equal to I plus 1 you say here, and repeat this step by checking one condition, that is I less than or equal to 10. Okay. So after you accumulate sum with 2 into I, you have implemented I, and you're checking a condition I less than or equal to 10. If this condition is true, you are repeating this, right? So what happens now? After sum has been accumulated with 2, because I value was 1 initially, 2 into 1 is 2, 2 was there in sum, 0 plus 2, 2 was there, then I was incremented after it. So how much it would have been? 2. So 2 less than or equal to 10 is 2. Again, you come to this particular statement where we said sum equal to sum. Sum is in, now 2, 2 plus 2 into 2 is going to be 4. So 2 plus 4 is going to be 6 here. Then I will be incremented will be 3 now. Again, I is going to be checked with whether it is less than or equal to 10, and you are repeating this. How long? Until I is, 11. Because 11 is not less than or equal to 10. So when this condition is false, you will get the output in sum, so you are going to print it. So while you print, how do you print? You will be printing it with output symbol. So print sum. Okay, print sum value. That's it, right? Then you will end the procedure. How do you end? By say stop. By saying stop. So this is your flowchart, right? So this second question. I hope this is clear to all of you. Yes. Yeah. What is the next question we have? Describe the different types of operations that are included in C. What are the different type of operators? We have discussed this in the class, right? What do you mean by operator is a standardized function which helps you to carry out some operation. And we have classified these operators into arithmetic, logical, relational, bitwise, yes or no? And conditional or ternary. Conditional or ternary. Under arithmetic operator, plus, minus, into, divide, mod, all this comes under logical. Under logical, and we have, okay, This is said to be AND, right? And double vertical bar is said to be logical OR. Then you have logical NOT, right? These are some of the logical operators. Then relational operators like greater than, less than, greater than or equal to, less than or equal to, double equal to, not equal to, single equal to. All this comes under relational operator. And then conditional operator is question mark colon, right? And you have bitwise operators. What are the bitwise operators? You have bitwise and single ampersand is said to be bitwise, and single vertical bar is said to be bitwise or, and you will have exclusive or cap, right? And you have double greater than is said to be shift right. Yes or no? Double less than is said to be shift left. So these are the operators we have. Comma is also an operator because it is separating.
We also have ternary operator also.
Yeah, conditional is said to be the ternary operator. This question mark colon is also said to be the ternary operator. Basically, operators are of three kind originally. In general, one is unary operator, another one is binary operator, third one is ternary operator. Unary operators are the operators where you will have only one operand, single operand. In binary operator, you will have two operands. In ternary operator, you will have three operands, right? Unary operators like increment, pre-increment, post-increment, you know, decrement and all kind of things. I think this is, I'll just graph it, and then show you, okay? Fine. So under unary operators, you have increment, decrement kind, or pre or post kind, right? Yes, sir. And unary minus. Okay. So these are some of the unary operators. Then under binary, which we have discussed just a while ago, that all comes under binary operators, right? So under binary, you have arithmetic, like you have plus, minus, into, divide, mod, and in relational, like you have greater than, less than, greater than or equal to, less than or equal to, not equal to, double equal to, and single equal to. Then under logical, you have double ampersand is said to be the logical and, double vertical bar is said to be the logical R, and exclamation mark is said to be the logical not. And then you have bitwise operators, right? Under bitwise, single ampersand is said to be bitwise and, single vertical bar is said to be bitwise or, cab is said to be the exclusive or, and you have double greater than is said to be the shift right, and double less than is said to be the shift left. Okay, so this all comes under bitwise operators. These are all binary operators, right? So then you have ternary operators. Ternary operators, where you have three operands: question mark, colon. Before question mark, you have one operand, and between this, you will have another operand, and after colon, you will have another operand. This is said to be even the conditional operator also, right? Conditional operator, right? You know the usage of all this plus, kind of thing. I plus plus you will have, R plus plus I you will have. Okay? Similarly, plus plus minus minus I, R I minus minus. Okay, like this you will have. Conditional operator. How do you have conditional operator? For example, I have one condition: A greater than B. Question mark A colon. So now, how does this is going to be executed? C equal to, I have one statement, C equal to A greater than B, question mark A colon B. It works like if else. It is similar to, it is very much equivalent to if else. So the interpretation of this statement is, if A greater than B, it is assigning A to C. It means C equal to A. Else what it is doing? C equal to B. So this is the interpretation of this, right? So when the condition is first tested and found to be true, A will be assigned to C. Otherwise, B will be assigned to C. Got it? So here you can see there are three operands. This is one operand, this is another operand, this is another. So in ternary condition, you will have three operands, right? So that's the reason why we said ternary. Ternary means three. Binary means two, right? Binary means one. So these are the different kind of operators you have in C language. I hope this is clear to all of you. Fine. So next question is, write a C program to convert the binary equivalent of an integer number without using the array. Fine. So if you have a number like this 101, 101. So this is set to be the weight position of 2.0. This is the weight position of 2 power 1. This is the weight position of 2 power 1. So if I have to convert from binary to integer, how do I do that? 1 into 2 power 0, right? Plus this bit weight position into the bit. 0 into 2 power 1. Plus bit weight position is 2 power 2 into 1, right? So what is the result I'm going to get here? 2 power 2 is 4. 4 into 1 is 4. 0 into anything is 0. Plus 2 power 0 is 1. 1 into 1 is going to be 1. So this is going to be 5, right? So this is how I convert, right? Binary to integer. But now I have to write the program for the same. So here I am devising the logic. You can see. Let us take this number as n. Okay. Now divide this number and take the remainder out of it, right? With 10. So when you divide it with 10 and then get the remainder, you will get one digit. That is the last digit, right? So this digit which you get should be multiplied with the bit weight position, right? So let us take this in the bit. I say bit B. Now this bit has to be multiplied with the bit weight position. So what is the bit weight position? It is power of, I can say 2 comma I, where I is going to be varied. It can vary between 0 to 2. Fine. So I'll put this in a loop, of course, right? And this has to be accumulated with the sum in which I am going to get the integer. Let us say I am taking the integer variable name as I, okay? So I plus equal to b into power of 2 comma I. And this process I have to repeat it until I get my this, right? So until n value is 0. When all the digits are being taken out, what will be the remainder? It will be 0, right? So you will be performing, and then see, after you reduce the number, how do you reduce the number? You do it with n by equal to 10 or n equal to n by 10, right? N equal to n by 10. Right? This whole to be repeated. How long? Until n is not equal to 0. So I'll take a for loop here where the I value starts with I value starts with 0. Okay. And n, if already given a value, then let us take that value, and you will be repeating this process how long? Until n is not equal to 0, right? And then you say I plus plus, fine. This is the logic which I have built. You just check across this, what happens now. Correct. So just check across this. What is n? N is 101. Let's trace the program. N is 101 here. Now I value is starting with 0. So in this logic, fine. You are checking what? You are checking n is not equal to 0, right? So n is not equal to 0. Here you come to get a bit out of it. How do you get the bit? By performing division and taking the remainder out of it. How do you perform the division? N by 10 here, right? So when you perform n by 10, that is 101 by 10. How do you do that? N ones are 10, right? You will get 1 here, and this is how you perform it rather. So 1 is the remainder you get out of it. So B value will be 1 here. Now I is initially 0 here, capital I. This I is different and this I is different. I is 0 here initially. So it was 0 before. Now small I equal to 0 you have initialized, and then n not equal to 0 is true. You will be moved on inside, then you're performing n mod 10. You got B value is 1, the remainder out of this particular division is nothing but the last digit out of it. Then here what is that you're doing? B into power of 2 comma I. What is B? B is 1. 1 into power of 2 comma I. 2 I is 0. 2 power 0 is 1. So 1 into 1 is going to be 1 here. So I plus equal to, this means I equal to I plus. So 0 plus 1. Yes, sir. So this will be 1. This will be 1. The next thing that you have is n equal to n by 10. What is n actually? 1, 0, 1. When you perform the division, the quotient out of it, what is that? 10. So here what do you get? You will get 10 here. So after this again you go back to next iteration. When you go for the next iteration, I becomes 1 here. And n not equal to 0, n is 10, 10 not equal to 0 is 2. Again you are allowed inside. Then what is that you're going to do? You perform n mod 10. What is n mod 10? 10 mod 10. So when you perform 10 mod 10, 10 ones are, you will get, what is the remainder? 0. So what will be B value here? B value will be 0. Then here I equal to I plus, we set this, right? So I is 1, 1 plus B into power of 2 comma I. What is B here? B is 0. 0 into anything is going to be anywhere 0, right? So you will get 1 only, right? You get 1. Then again you have n equal to n by 10. So what happens? N is 10 here. 10 by 10, the quotient is 1 here. So that quotient you are assigning to n. So n becomes what here? 1 then, right? After this again you go for the next iteration where I becomes 2. And n not equal to 0 is true because 1 n value is 1. 1 is not equal to 0 is true. So you are allowed inside. Then again you are performing 1 mod 10. How do you perform 1 mod 10? Right? N zeros are 0, you find the remainder as 1. So what is the remainder you get? 1. So what will be B value then? Obviously 1, right? Then next step you have is I equal to I plus. I is 1, 1 plus B into power of 2 comma I. B is what? 1. 1 into power of 2 comma I. I value is what? 2. Means 2 power 2. 2 power 2 means 4. So this is 1 plus 4 is going to be how much? 5. So I value will be 5. Then n equal to n by 10, when you say, what is n actually 1? 1 by 10. What is the quotient? You will get 0. So what will be n value here? It will be 0. Yes or no? So again, when you go for the next iteration, this condition is false. So you come out of the loop and you got the result in I. Yes or no? So this is your code. Now if you have the code, you can write the program for the same. Yes or no? Can you write it or not? This just you have to declare the variables. What are the variables you have here? Small I, capital I, and then you have capital N, then you have capital B. Yes, sir. So these are things you can declare, and you can have some statements to read n value, the binary value, right? Printf and binary number. So percentage d ampersand n. So after this is the logic, right? After this logic comes here, this entire logic. You write this logic here. Then after you write the logic, the entire which I have discussed before, print the result. Where the result is available in I, right? So integer equivalent of binary, integer equivalent of binary equal to percentage d, where you can print the I value. Got it? Then you can terminate. Got it? So shall we move on to the next question? Yes. So the 12th question we have discussed, right? Write a C program to convert the binary equivalent of an integer number without using array. Explain how arrays are passed to a function with an example. This is the next question. 13th question. So shall we see the next question? Yes. Yeah, what is the next question here? How to pass an array to a function. So let us say, take an example of finding sum of an array. Okay. So we have worked out examples with binary search, linear search, sorting, and all in the classes. Anyway, I am just taking a small example here. Sum of array. You will have to declare one array here. Basically, a variable followed by square brackets is being identified with array, identified as an array. So here you can have the logic to find the sum of an array. Sum equal to sum plus a of r. Okay. So this is the logic you have written. Now this is a function in which you are finding the sum of array. Now when you want to implement the same, you will be implementing it for the main, of course. So in main, you will be declaring an array of some size. You need to read it as well. So I'm taking another variable I here, x, n, and I. Okay. Now first you read the array here, and array elements. Before that, you want to read the size of the same. Enter size of. Okay, then first you read the size of the array. Then you can read the array elements. Of how much size? Percentage G size. Where this size we have read before itself, right? So now we are reading the array. Scanf percentage G ampersand A of 5. This is how you read array, right? Then you need to call the function which is returning you the sum of an array logic. So I am directly calling here the print function sum of array equal to percentage D sum of array. Actually, I'll take this also a no issue. I can have a declare here and then no issue, or I can have declare name also. Fine. A comma size of the array. Okay. Now terminate the main function. So look at this program here. So this is sum of array function wherein the function is taking array A and then N. There is one variable, integer variable, there is one integer array. Two of them are being taken as the arguments. These arguments are said to be what? Formal arguments, right? To the function, right? Now inside this function we have the logic to find the sum of an array. So you can see there is a variable, sum we have taken, as 0, and then we have accumulated these array elements into sum, and the same is being returned here. Now to implement that in the main, we have taken an array here. This is the array for which the memory going to be allocated, right? And you have n and I. You are reading elements into array. Let us say if the n value is 5, then you will be reading for how many? 5 elements, right? Once you finish reading for 5 elements, then you are calling that function. That function name is sum of array. So when you are, you can see when you are calling the function where I need to pass the array as an argument, what is that you're passing? You're just passing the array name, that's it, right? Array name, comma, here this n, if we have taken, this a and n is local to this main, and this a and n are local to this, right? But then in case of arrays, what happens? This is your actual variable, this is your actual array. So the time of calling the variables which you pass are said to be the actual variables, right? Actual parameters. So these are the actual parameters, and for this actual array, the memory will be allocated, and these are said to be the found parameters. And in case of array, what happens? If you are passing an array, you just pass an array name, and the formal array name will act as an alias name to the actual array, right? So here, call by reference concept is being implemented. In case of variables, call by value will be implemented. So what happens when you pass n value which you have read, that will be copied into this n. This n is local to this function. So this n will be copied into this n, right? And that n is accessible here. This n will be accessible here. And this a, which you are passing as an argument, this is our actual array where it is available. It is available in main. So the array name when you pass, this array name is also a. You can have some other name also, no issue, right? So this will act as an alias name to this array, and it will access the original array only, fine. And then it will do. In fact, this is how the logic behind how the array, when you pass the array is being accessed, it's at the function side. Basically, in function, for formal arrays, the memory will not be allocated. Rather, they will just act as an alias name to actual array. So this concept is being implemented with call by reference concept. Whereas when you have variables like this, fine, the values are going to be copied. So this will be implemented with call by value concept, right? So you have two type of calling while you're passing the parameters, call by reference and call by value. So this is a mix of both. You have call by value and as well the call by reference. But you can now, for this particular program, what is that you need to explain is how you declare the array in the function definition, and when you want to implement the same at the time of calling, how is that you are going to pass the actual array, right? So you pass the array name, that's it. In the function definition, you declare it with square brackets. When a variable followed by a square bracket will be identified as an array. Okay. So, and if you want the entire mechanism what I have discussed, you can explain all this. It is well and good, right? Explain all this mechanism which I have discussed. Okay. So now we'll see the next question. This is the 13th question which I have discussed. Since it is under 10 marks asked, I want you to explain whatever I have explained. This concept is implemented with both call by reference and call by. So array concept is being implemented through call by reference concept always, right? So you can explain what is that I have explained in this example because it is asked under 10 marks, right? So just writing example is not enough. Explain that entire thing, the mechanism behind it, right? So what is the next question we have? We have the next question is how do you define a structure within a structure? Explain with an example. Got it? So structure within a structure is said to be what? Nested structure. We have discussed one example of date, right? For example, you want to declare the date. Date consists of, let us say, three attributes. Right? It will have day and month and year. Right? So the structure consists of three members, day, month, year. All three of them are integer. Right? And then I have, let us say, another structure of employee. Right. So in this employee structure, I have variables like employee number, employee name. To take character pointer will be treated as a string. And here I want date of joining and date of leaving of the employee as of date kind of structure. Okay. EOJ, comma, EOL. Now terminate the structure. How do you terminate the structure? With the help of a semicolon, right? So in structure employee, you have DOJ, DOL are the members of date, where date is a structure. This is said to be structure within a structure, nested structure. Okay. So if I have to access the elements of the nested structure, how do I access? Well, basically, I need to create a variable of employee kind. I just say employee for termination. Now, uh, so to access, let us say DOJ, how do I access? E dot DOJ, right? But then DOJ is a structure wherein you have three members, day, month, year. So how do I access that? Again with the help of another dot, right? Date. Double dot, right? This dot is for accessing the member of the employee, and this dot is to access the number of date, because DOJ is a number kind of date structure. This way you can have. When you have nested structure, you will have dot dot kind of thing, right? I hope this is clear to all of you. So you can define a structure within a structure with the example which I have mentioned. Explain the same, right? What is the next question? 15th question. Why pointers should have data types when their size is always 4 bytes in a 32-bit machine, irrespective of a variable they are pointing to? Yes. See, this is a very good question actually asked. Until you will have the issues of pointers, the problems that are being encountered while using the pointers and how those issues are being resolved, you can't answer this kind of questions, right? So the question was like, why pointer should have a data type? Well, it is always basically data type is judging the memory to be allocated for a particular variable, right? Data type basically, if I have a variable a, I want some memory to be allocated for it. I use some data type. So when I declare it with integer, I get 2 bytes of memory allocated. Right? It is a float, it's a 4 bytes. So data type not only defining the characteristic and the kind of operation that I will perform on it. In addition to that, how much memory is going to be allocated for the particular variable is also being judged by this. So in case of pointer, we are clear. If it is integer pointer, or it could be a float pointer, it could be of any kind of pointer rather, right? For all of them, how much memory being allocated? A memory required to hold 1 byte address. If it is a 32-bit machine, 4 byte. If it is 16-bit machine, 2 byte. If it is 64-bit machine, it is a 8 byte. So that is constant, right? So the amount of memory required is constant. But still, why do you need the pointer when you're declaring? You need a data type, right? This is to basically resolve an issue called aliasing and dangling pointer. Dangling pointer, okay, is the issue which is being resolved, which is being encountered during aliasing. Right? Then what is aliasing? You need to know first, right? When a particular memory being pointed by more than one pointer, right? We say it is aliasing. How is it possible? You may ask. Basically, pointers are invented to perform the dynamic memory allocation and deallocation. That is, during the runtime, you want to get some memory allocated, and then you want to deallocate the memory as well at the runtime. These pointers were basically essentially needed, right? So you have heap. One memory is said to be heap. One is another wherein you probably most of the time you get it allocated for your most of the operations like expression evaluation and function recursion and all is this stack. So stack memory and heap memory. Fine. Stack is being allocated immediately after you start the execution based on the machine. For every task, how much stack memory is required, it is allocated. So you perform a stack operation in the stack. But then heap is available for all. Fine, this is not fixed. It is common to all. Anybody can go and then get some memory from it, right? So I need some memory to perform some operation. I'll go and then fetch this memory. How do I own the memory? By knowing its address, right? If I have the address, it means I can go there. I can trace there. Once I go there, I can access it. If I access, I can rather perform some operation at the same. So if I have, if I have the address, I can access as I said, right? So in order to hold this address, we need pointer. Pointer basically is what is holding the address. Right? So if I have some variable with which I can point to that particular memory, that variable I am saying it as a pointer. because this pointer is holding the address of the variable. The, you know, if I have some land, for example, fine. How do I claim the ownership of that particular land by owning the registration document? So you can say this is the registration document. So this address, if I have, then I say I am the owner of this, right? But at the same time, someone else, some other user, let us say P2, can also hold this address. Getting the point? So it means this memory can now be pointed through P1 and P2. This concept is called aliasing, right? Now the issue comes when aliasing is encountered is P1 does not know that P2 is also owning it, and P2 does not know that P1 is also pointing to the same. If P1 uses, then P2 will be left dummy, and if P2 uses, then P1 will be left dummy. So the dummy pointer is said to be the dangling pointer, right? After being pointed to some memory, is unable to use it because someone else have used it before he uses it, rather, right? Because there was some other pointer who was pointing to the same, fine, which he does not know. Got it? So, in order to resolve this issue, what is that we need? When you own the memory, immediately you will impose some restrictions on this. Okay, you will impose some restrictions on this. Got it? So, how is this possible? By assigning the characteristics of some data type. So if I declare that pointer P1 instead of void like integer, then what happens? This pointer is being able to use integer, you are saying. So at the time of allocating the memory, how do you get the memory allocated during the runtime with the help of what? Memory malloc function. Okay, malloc function. So what malloc function does is it resolves all these issues. So if you look at the syntax of malloc size of, let us say you want to get some memory allocated for employee structure, you say struct employee. Yeah. So malloc size of, you want to, let us say for example get some memory allocated for employee structure, say struct employee. And then you're imposing the restriction here with the help of casting, right? So here you're mentioning struct asterisk. And holding it in some pointer. There the pointer is of employee kind. Now what happens? This malloc is going to allocate the memory required for this employee structure. Okay. So employee structure, let's say, consists of some members. So for all such members, whatever the memory required, it will allocate. And then with the help of this casting, right? The restriction imposed, right? The restrictions are going to be imposed on this, saying that this can be used for employee kind. And this now going to be pointed through P. So the first byte address is nothing but the base address. It's going to be returned and which is going to be held through P. Now P is pointing to this entire memory. Fine. So now you can see there is no kind of aliasing or dangling pointer issue being raised, because at the time of creating the memory itself, we are imposing the restrictions on the same end, holding the base address of the same with the help of a pointer. So there is no chance that another pointer can come and claim it rather, right? You are not giving room for other pointers to claim the same, right? So in order to implement this, since this memory being imposed by some restrictions of employee kind, then you may need a pointer to hold the same with the same kind. That's the reason why the pointer at the time when you are trying to declare, you need to declare it with the help of data type. Got it? So this is the reason why you need to declare a pointer with the help of data type instead of without. Of course, you have void type and type of pointer concept as well. So if you declare a pointer of void kind, this pointer can point to any kind of memory at the time of execution. So that is another option which is opened, of course, with pointers. Now this is clear to all of you. Yeah, what is the next question? What are the primary advantages of using data files? You can perform all the operations. There are, file read, file write. You have, seeking, rewind, inserting some data in between. All these operations. All these operations you can do it, you know, very easily with the help of operating system, because these all kind of file operations are being carried out with the help of operating system. You not to install any separate software, right? So you can perform all these operations with the help of operating system directly. All these functions that you have as part of the C, C++ libraries or any other programming libraries, these are going to directly interact with the operating system calls, and then get you the required task done for you, right? Next question is, how is a structured data type different from an array? Structure is a set of heterogeneous data elements. Array is a set of homogeneous data elements, right? Explain with an example. You know how to explain. You just take an example of array and structure. Explain it. Write a program that uses function to search a number with an array. Here, it was not mentioned whether it is to be implemented with linear or binary. You can take any of the mechanism and implement it, right? Distinguish between the following with example. Distinguish when asked, you have to give examples. Do while and while loop. Do while is a post test, while is a pre-test. Okay, this is a difference. In pre-test, what happens? You first test the condition, then you will allow the user to execute. In do while, what happens? You will first allow the user to execute, then you will test, right? This is a post-test. In break and continue, break will simply break the loop. Continue will allow the user to go for the next iteration by skipping the followed statement. So this is all about the first paper. Probably we'll discuss next paper tomorrow.